So in this video, I'm going to discuss the concept of acceleration. So acceleration is when you change your velocity in some unit time. It also can be stated by writing the rate of the change in velocity. So rate is, whenever you see that, when you're asking the rate, it's something over time. So just kind of keep that in mind because that's another way that it can be worded. All right? So in order to change your velocity, remember that velocity is a vector. So velocity has both a magnitude and a direction. So there's a couple of different ways in which you can change your velocity. If you are going to change the magnitude of your velocity, it means that you are speeding up or slowing down. So it's essentially changing your speed, right? However, we can also change our direction and be changing our velocity, and so in that instance, we would be turning. But for the most part, for our calculations starting now, we're going to be dealing with this sort of acceleration. Conceptually, we can understand this, but we'll get to this more when we talk about circular motion, which will be in a few units. Okay? So the equation for acceleration is that acceleration, which is written with an A, is equal to the change in velocity over time. Now, remember, the change in velocity is also written as v final minus v initial all over t. And this equation sometimes is rearranged to solve for v final for some reason. So we can also see it written like this. Let me put it on a different sheet of paper. So we have this, A equals v final minus v initial all over t. This means initial as well. Oops. And so we're just going to solve for v final. So in order to do that, we'll multiply by t on both sides. Whoop, you can't see it. There we go. We're going to multiply by t on both sides. So we end up with AT equals v final minus v initial. And then we add v initial to both sides. Here, it cancels. And so what we end up with is, and I'm just going to kind of flip-flop because this is how I think it looks in your reference tables. So v final equals AT plus v initial, or v initial plus AT. But again, it's all just some basic algebra. This, and this are all exactly the same. Okay? So let me just do an example. So let's say that a car accelerates at a rate of, let's say, 12 meters per second squared. I'm just making this up. I have no idea if that's a realistic value. So we could ask ourselves, like, what is the velocity? So what is the final velocity? That would be my question. After maybe like 3 seconds has elapsed. So after a time of 3 seconds. So in this case, because I would be solving for v final, I'm going to want to use this equation. Now, the other thing is there's some things that so I told you I gave you these two pieces of information, so that was what you're given. However, there's something that could be applied from that problem. So if something speeds up at a rate of 12 meters per second squared, we can assume that they start from a stop, or they start from rest, unless it indicates otherwise. So another piece of information that we know just from the wording of the problem is that the initial velocity is equal to 0 meters per second. So then I would just solve for this, for v final, and I would say, well, v final is equal to acceleration, 12, times time, 3, plus 0. So in that case, after 3 seconds, that car is going to be going 36 meters per second. Right? So this just kind of gives you an example problem. So if we look at this unit, so I gave you the unit for acceleration was meters per second squared. So where does that come from? So if we go ahead and we look at the equation, so acceleration equals velocity over time. Remember that the unit for velocity is meters per second, all over seconds. So sometimes the unit for acceleration is written as meters per second. But also we can take this, and remember this is seconds, so if we divide by a number we can invert and multiply. So it's the same as saying meters per second times 1 over seconds. So that also gives us meters per second squared. So these are the units for acceleration. Now the last thing that I want to talk about in the video is graphing. Okay, so I'm just going to do a brief graph. So in the previous video we talked about a position versus time graph. And something that's going a constant velocity, so its velocity is not changing over time, is going to have a constant slope. So for a position versus time graph, you're going to have something linear, and it can have some positive, it can have some negative, or it could have just no. All of these instances right here are example of a constant velocity, or acceleration equal to 0. All right. Now, if I were going to represent an instance where there was an acceleration for a position versus time graph, that means the slope of the graph would have to change over time. So it's going to be some sort of curve like this, or curve like that. So in this case, there is a change in the velocity, and there is some acceleration. So there's either a positive or negative acceleration. So when we see this curve, we know that in every time instance, we're moving more of a distance, so our velocity is increasing. And remember that I said that the line tangent to the curve gives you the velocity at any moment. So you can see that if I move this pin along like it's the tangent line, that the slope of that line is increasing. So the instantaneous velocity, or the velocity over time, is increasing for that instance. Whereas here, it's increasing but in the negative direction. Okay? Now let's look at an example of a velocity versus time graph. So those are position versus time. But let's look at velocity versus time. So if I graph velocity here and time here. Now, if I draw any straight line, no matter where it is, those are all examples of constant velocity. However, so these are constant velocity. So when we have constant velocity, we're going to say that there's no acceleration. But if I want to show a change in velocity or a changing acceleration over time a changing velocity over time, it would be something with a slope. So something like this or something like this. Okay? So in this instant, these show acceleration and a changing velocity. All right, and we'll do more with graphs in labs and analyzing graphs. But for now, that should give you a general idea on the background information you know to or need to understand acceleration.